A lot of things in life happen over and over again. It is repetitive, or we call that a loop. There are multiple ways to implement a loop in C. We will start from the very basic ways, which are the for loop and the while loops. Why do we need to use a loop? Consider the following program. This program prints out a single star in a line. What if we want 5 stars in 5 lines? We could do this. Copy and paste 5 times. Then we get the 5 stars. What is wrong with this approach? Actually, nothing. It's a perfectly good way to print 5 stars. But what if we need to print 1,000 stars? Then we need to do it like 1,000 lines of code. And what if we want to change the star to an X? Then we need to change like 1,000 lines of code from star to X. What if there is a way that we can do something like this? We need a way for us to write something called repeat 5 times and then have the programming language repeat the same thing, the same command inside this yellow box over and over again for 5 times. And we can change the number 5 here to 1,000 and it will repeat 1,000 times. We can also change just the letter here just once from star to X or Y, and then it will print that character 1,000 times. Well, we cannot actually write repeat 5 times inside the C language, but we have something very similar. It's called a for loop, and we will do it like this. Let's look at the result. There, you see 5 stars as expected. Let's look at each component of this for loop. First, you see that there is a variable I that is declared here as an int. It doesn't have to be I, it can be any name that you want. We call that the index variable. Or sometimes it's called an iterator. Iterate just means to repeat over. It is usually an integer, but it doesn't have to always be an integer. And you see this first part, I equals 0, that first part is called the initialization. Initial just means to start, the starting value of I. And the second part here, you see I less than 5, that is called a condition. That means as long as I is less than 5, it will do the thing inside the loop over and over until this condition is not true. Let me repeat again. It will do the thing inside the loop as long as the condition is still true. Once the condition is false, then it will stop the loop. So you see, I start from 0. It will go on as long as I is less than 5. Once I is equal or greater than 5, it will stop. But what if I never change? If I never changes, then it will never reach the value of 5. So that means there must be a third part to change the value of I, which is this third part here. This part is sometimes called an update. It's the thing to do after each loop. So this is the basic anatomy of a for loop in C. And surprisingly, in many other languages, the for loop looks very much the same as in C because all those languages are influenced by C. It may be a good idea for you to take a screenshot of this screen so that you can keep it for reference later. Let me explain a little bit further. When the program enters a loop, it will start by assigning the value, the initial value, to the index variable. In this case, it's I. And then it will check if the condition is true or not. Of course, 0 is less than 5. Then once the condition is true, it will do the thing inside the loop. And only after it does things inside the loop, then it will do the third component of the for loop, which is the update of the I variable. I++ just means incrementing I by 1. It's the same as I equals I plus 1. So now I will equals 1. And then it will check if 1 is less than 5. And yes, it's correct. So it will do the thing again. And then it will do the update again. I now equals 2. Then it will repeat this over and over until I equals 4. Then it will add 1 to I, and I will become 5. And when I equals 5, this condition is no longer true. Once the condition is false, the program will exit the loop. So this program will be executed exactly 5 times, from I equals 0 to I equals 4. But when I equals 5, it doesn't do it. Actually, we should print the value of I from inside the loop to check if that's true or not. Let's do it. Now you see 0, 1, 2, 3, 4. Those are the values of I. You may ask, that's quite unnatural. When we think of a loop that repeats 5 times, we think of a loop that goes from 1 to 5, not 0 to 4. Well, in the C language, people like start from 0. But you can have it your way. You can have it goes from 1 to 5 as well. Let's do it actually. I will start from 1. And when I is less than 5, it's okay. If I equals 5, then it's okay too. And then for each loop, we will increment I by 1, the same as before. So now let's see if that will print I equals 1 to 5. Aha! As expected. Now I feel like fun. What if we want to change it? We want it to start from 2, 4, 6, 8, 10. What do we need to change to make this happen? I will have to start from 2. And then, what should be the condition here? We will do it as long as I
It's 2, 4, 6, 8, 10. 10 is okay. 11, not so much. 12, no. So,
we will do it as long as I is less than or equal to 10. What else do we need to change? Let's hit pause for 2 seconds and then think about it. Okay, that's right. We need to change I by 2 each time, not just 1. So I++ here need to change it to I equals I plus 2. Let's see. 2, 4, 6, 8, 10. That's right. There's another way to write this statement here. We can change it to I plus equals 2. That will add 2 to I. Let's see. 2, 4, 6, 8, 10. Good job. So we see that the index variable does not have to go 1 by 1 forward. It can go by 2. It can increment by 2 or 3 each time. It doesn't matter. It can double itself every time as well. It can also go backward. What if we want to change I to start from 5? And then we will do it as long as I is greater than 0. And then for each time we decrease I by 1. We will write I minus minus here. What do you think this will do? Of course, it will still print 5 stars. But what are the numbers after the stars? That's right. It's 5, 4, 3, 2, 1. So you see that the for loop in C is very flexible. It's highly flexible. It's almost too flexible. It doesn't matter what you put in the third box here, as long as the condition in the middle box goes to false at some point. But what if we remove this condition altogether? Then I will never change. So this condition will never be false. So the loop will never stop. Let's see if that's true. You see, that's not all the output because it's still printing all the time. It doesn't end. It's called an infinite loop. And when it happens like that, it's usually the result of a bug or an unintentional error inside the program. But We sometimes use a for loop to write an intentional infinite loop. It's called a forever loop. Just like that. There's nothing in there. No starting condition, no initialization, no update. This program will just go on and on forever. And the forever loop looks like a useless loop, but it's actually very useful. Sometimes we use them for event loops. That means a program that doesn't end, a program that responds to event in 3D graphics or in a game and input detection. The loop will just keep looking for a keyboard or a joystick or a mouse input and then respond to that input. Or in a server application where the server just sit there forever and listen to the port. If there is an incoming connection, then the server will process that data. Fun fact, Infinite Loop is also the name of a street in front of some company's headquarter. And I took this picture like 14 years ago in front of that company. Yes, that's really me. Okay, let's do something useful with our for loop. We will ask the user how many stars do they want. We will get an input of an integer. Then we will print that many stars and the program will end. Let's run the program. So I say 7 stars and I get 1, 2, 3, 4, 5, 6, 7 stars. If I want 100 stars, then I will get 100 stars. Let's see. If I want negative 10 stars, it doesn't print any star. It also doesn't print any error code. What if we want to detect if there is an error here? We want to validate the input. How can we do that? Let's take a look at the code. Where do we take the input? It's this line here. Scanf. So after we take the input n, then we can check if n is greater than 0. If it is less than or equal 0, then we can ask the user for another input again. We can use an if statement just like this. If n is less than or equal to 0, then we can do another scanf, and it's the same command. This approach would work if the user accidentally put in the wrong number on the first try, and then after the second try, the user put in a good number, that is a positive integer, then the program will work correctly. But what if the user enters negative number again at the second time? I don't know why, but sometimes it happens. This program will not ask the user for another input for the third time. What if we want to keep asking the input from the user until we get a valid response? Then it cannot just be an if statement. It needs to be something that repeats over and over again. We use a while loop for that. And the while loop has a syntax like this. That is, while this condition is true, as long as this condition is true, then it will keep doing the thing inside the bracket. And after it does the thing inside the bracket once, then it will check the condition again. And if it's still true, it will do the thing again. And it will check the condition again over and over. How many times we don't know in advance. We have to check it at the beginning of each loop. So the condition may change and the while loop may execute or may not execute. That is exactly what we want, because as long as the input is still invalid, then we need to keep asking the user for another input. So let's do that. So while n is less than or equal to 0, then we need to keep asking for another input. And also maybe we want to complain or we want to put out an error message as well. Let's try. -5.
Please input a positive integer. Let's put 0. That's still wrong. Let's put -100. That's still wrong. -7. Still wrong.
19. That's good. Okay, let's try again. 200. That's good. I will not count it. But let's put 5,000. Oh, that's way too many. That's way too many. Let's say we want just any value of n between 1 and 1,000. We don't allow n to go over 1,000. What do? We need to add another condition, or we need to combine a condition using a boolean operator. So we do it like this: while n is less than or equal to 0, or n is greater than 1,000. We don't like it. Then we need to ask again. The word or here is not valid in C. The way we implement a logical or is that we use the pipe character like this. Double pipe characters. That's or. And this one will be and. Double ampersand. But we need to use double pipe here for or. Where is the pipe character? On the upper right hand corner of your keyboard here. That's the pipe character. You need to press shift to get it. Let's also modify the error message a little bit. Please input a positive integer that's not over 1,000. Okay, let's try. How many stars? -7. Error. 5,000. Error. 500. That's good. So that's how we use the while loop to validate the input and keep asking for the input until it is valid. Notice that this is just one way to do it. There is also another way. I want to show you just one more way to do it. Some people feel that this condition here is just too cluttering and it makes the program more difficult to read. Why is it difficult to read? Because when you think about the condition that the input is valid, it is actually the opposite of this condition. The input is valid when n is greater than 0 and n is less than or equal to 1,000. But when we use a while loop like this, we need to invert that condition to be the opposite, and that is more difficult to do in some cases. So we want to write a program that's very easy to debug, very easy to read, something like this. First, I want to declare a new variable called valid. Valid is an integer, but actually we want to treat it as a boolean variable. A boolean variable is like a logical variable. I can see it in your eyes. You are wondering why? Why is a logical variable the same as an integer? Well, it's a feature of a C language that treats all logical variable actually as an integer. There's no such thing as true or false in C. Actually, C only recognizes 0 or non-zero. Anything that is not 0 is true. Anything that is 0 is false. So C decides that there's no need for a separate kind of variable that is called a boolean in other languages, or sometimes we call it a logical variable. So valid, although it is declared as an int, we will treat it as a true or false variable. But instead of saying true, we will say 1, 5, -1, doesn't matter, 100, 42, doesn't matter. Instead of saying false, we will say 0. That is the same thing as false. So let's do that. Let's say valid is a logical variable that represents the status that the input from the user is now valid. At first, the user hasn't put in any input, so it is invalid. We will say valid is false, so we give it a value of 0. That means false. Now we will write a while loop that keeps doing something as long as the input is invalid. It's not valid, right? So we say while valid equal 0, do something to get input and maybe shout out some error messages. Let me point you to this statement here. This statement is correct, but it is not typical to write it like this. If we want to treat valid as a boolean variable, we don't say it's equal 0. That's like treating it as an integer still. So if valid is false, then not valid is true. So how do we say not valid in C? We use the not operator, and it is just the exclamation mark like this. So we say exclamation mark valid. That reads not valid. Okay, first we do something to get the input. That's easy. Scan F %d, and we give it to the address of n, and maybe shout out some error message, but we don't know yet if the user input is an error. So we need to check it. And how do we check it? We check it and we keep the result in the variable valid. We say valid has a truth value equals to this condition. When do we say that the input is valid? N has to be greater than 0. And n has to be less than or equal to 1000. And for clarity, we always use the parentheses. In this case, technically, the parentheses are not needed, but they make the code much easier to read. And then we say, if not valid, then we shout out some error message. Please input an integer between 1 and 1000. And let's try. How many stars? -5. Please input an integer between 1 and 1000. Okay.
5001. Error. Let's say 0. Error. -100. Error.
6. That's correct. Let's try again. And what if we do it correctly on the first try? 10. Then we get 10 stars. So that's good. So that's how we use a while loop. Okay, you see that a while loop and a for loop can be used interchangeably. But also, can we use the while loop as an infinite loop? Yes, we can. We can do it like this. The number 1 here just means true. You can use -1, you can use 5, you can use 10, doesn't matter, as long as it is not 0. So what does this program do? It will keep laughing forever. Let's see. Okay, let's stop. In this video, you have learned about basic loops in C, the for loop and the while loop. In the for loop, you have learned about the basic component of a for loop, the initialization, the condition, and the update. You have learned the basic patterns for a for loop. The linear iteration can start from 1, 2, 3, or it can go backward, it can go forward. It can skip some values. You know about the starting and the stopping value. You can go forward or backward. You have learned about the infinite loop or the forever loop. That is sometimes unintentional, or sometimes it is intentional, and it is very useful in some applications. For the while loop, you have learned about the basic component. You have learned about the use of while loop as an input validation tool, and it can be used as an event loop as well. You have seen a few ways of making conditions for the while loop. You can use a basic condition like n is greater than 0, or you can combine two conditions together using the operators like the ampersand, or the pipe. You can also declare an int variable and treat it as a boolean or a logical variable and assign a value to it so that your program will be easier to read and debug. The use of for loop and while loop that you have learned, together with the condition statement like an if then else, will make your program very powerful. It is a way to unleash computational power of the computer. Notice that so far we have learned each kind of structure separately. We can combine them, or we can combine the same thing together to create a nested loop or a nested conditional statement that is more complex and more intelligent. And just like everything in life, you start small, start from the basic step, and you repeat, keep doing it until you are very skillful at that. And then you go to a more complex operation. And you have learned a lot. Good job, and keep practicing.